Okay, this next session is going to be done by Mr. V. Amar, APAC's pre-sales lead for IoT solutions, Siemens Digital Industries Software Limited. Could I please request him to join us on stage? Ladies and gentlemen, let's welcome him, please. Do you want to use this one or this one?
I mean, anything is okay.
Anything you're comfortable.
Yeah, I'll just go with this.
Okay, and the timer is there.
Yeah. Hi everyone, very good evening, and it's been a pleasure to be part of this session with you all today in the evening today, and thanks to the organizers as well. I mean, what I have planned for this session is, I know I am the last guy, I don't take much time of yours, but again, the whole idea is to give you what we as Siemens kind of provide in terms of technology when it comes to closely related to your area of industry, and probably touch base a bit on a couple of challenges the industry is facing and how these challenges are being addressed to various solutions portfolio what we have. I'm not going to talk much on the product. Probably I'll just try to give you some insights into those. I don't have to talk about this, but what I want to bring here is the kind of impact mold manufacturers or molding industry or tooling production have in terms of different verticals of the industries, right? So, when it comes to the challenges, right, one of the key challenge is you're really working under great pressure. Why? Because the customer comes, he says, I want the very best quality, very good accuracy and consistency. Again, with what? With short-term delivery times, with low cost, right? This is a big challenge what we face, correct? And not only this, there is also problem with talent, right? We have to really struggle in terms of getting right personnel, right? And that's how the industry is getting kind of, hindrance in terms of productivity, right? So, one of the key thing here is the quality, right? Even though we have NC code, the issue is NC code can really make the things faster for us, but again, the challenge is if you end up with a low quality product in place, it's pointless, right? So that's one of the big challenge. And second one is the speed, right? We talk about speed. I mean, I would say one of the major trends in the industry today is multitasking machining tools, sorry. So you can pretty much accelerate your entire production. But again, these systems have brought kind of complexity into your process as well as the systems assured with them. Now, usually your competition is generating high quality products with very faster rate, right? And as one of sir was talking about, price and time has really become the key critical success factors for your industry today. Now the second thing is, now this really brings two major questions. What are the questions? Now the first thing is, how can I really generate that high quality products to my customer faster than my competition? Second one is, how can I help my customer to really come out with high quality designs right first time, right? This is where the entire industry today is struggling across. So now coming to the latest trends, and most of you have talked about this, touched base about this, but just to summarize, right? Today if you look out, you have 3D interactive designs and manufacturing process which can be shared across. It's now more about collaboration, right? All the involved teams can able to get and interact with the customers, and that's where it's bringing a lot of value in terms of reworking, or I would say rather accommodating customer changes, correct? The next one, when we talk about process automation, automation has really grown to the level where you can even go and generate high predictable NC code, right? That's where the direction is towards. Now, what this really is bringing onto the table, it reduces human error. It also reduces, the risk of human error. Sorry for that. So, now, obviously, the additive manufacturing, correct? Now, it's a continuous trend that's going on where additive manufacturing is being educated to different mold manufacturers. The reason being, it brings a lot of prospects in terms of making high quality molds, right? But again, there is a new trend that most of us are thinking about, or talking about, right? We are talking about Industry 4.0. Now, what is it? In simple terms, it's cloud computing. It's also, connecting your assets. It's also bringing new technological aspects such as AI and ML, which can bring a lot of changes in your day-to-day life. So yeah, the whole idea why I bought this particular slide is, most of you, probably I'm just assuming, sorry if I am wrong, might be using NX, which is a product of Siemens. Now NX brings, high industry lead capabilities into the one single platform, which can help you to really accommodate your day-to-day entire tooling design process into one single platform, right? You don't have to plug on into different silo systems, rather it brings everything onto the table. You can also accommodate changes. So that's the value NX brings in. Now the big story is this one, right? Now till this point of time, we are talking about designing, right? Development of your tool. Now what we are looking at is what exactly happening at the plant, right? When I'm manufacturing something, right? That's the major problem today. Because there's much of adoption that has happened, but adoption in terms of Industry 4.0 is still a challenge. Now, if we don't have that, what is that we are going to face, right? You can see the list here. I don't have to really walk through this because most of you might have got a knowledge on this, but this just to bring an understanding to you all. But what this also brings into the table is two major questions. Now, if I have to adopt this, do I nearly have to go and change my existing assets, replace them, or can I go and modernize using some existing technology where I can increase the age of my existing infrastructure, right? That's the overall thought, right? So, again, it depends case to case. If you have deep pockets, you can go for, very good new latest infrastructure into the place. But again, most of the time, we have existing infrastructure. The point is, it can be sensorized, right? That's what the overall idea is. Now, what I want to bring here is a couple of elements, because in terms of Industry 4.0, there are a lot of misconception going around, right? People think it's very costly. Probably I have to invest more. It's very, very, challenging, right? But let me tell you a couple of things here. If you really want to go and adopt to any Industry 4.0 solutions, there are 9 milestones which you have to really think through. The first one is understand your critical assets, right? Either it can be in your department, it can be your plant, it can be in your factory. Understand what are those critical assets, and then list down what is that operational parameters I need to have to really determine my KPIs, right? Now, once you know that, the third step what we advise is list down, categorize your assets. When I say categorize your assets, you have two types of assets. One is dark, one is live. So dark is not dark in color. The whole idea is these assets don't have any mechanism wherein you can extract the relevant operation parameters which you envision to kind of, determine your KPIs, which are pretty vital for your businesses, right? So those are the assets which we name it as dark, and there is no connectivity for them at all. Now the fourth one is live assets. These assets do have operational parameters, you are collecting it, but again, you don't have a connectivity, right? So this is what initially, we would advise to kind of do a kind of internal exercise. Post that, involve an OT expert, operational technology expert, who can decide what kind of sensorization, what kind of solution can be brought about to make your dark assets live and your live assets to get connected, right? That's the story what we are talking about. Now, post that, you involve the IT expert who can give you, okay, now if you really want to have a solution around this, how this solution would look like, what would be the infrastructure for it, and how it can help you, right? Who can envisage the kind of solutions you're looking at in terms of applications. Once you have this, obviously, everything needs money. It's come with a cost. You need to go through your APEX and CAPEX, kind of analysis or estimate. The next 2 steps are major steps. That's what we advise. Don't go and directly jump and start implementing your adoption. You start with a proof of value, which can be probably varying for a 2 to 3 month period. Take a critical but less complex, but again, you can see a kind of output from it. That is more important, right? So pick up that kind of element and then try to have this proof of value executed, then decide on the ROI. Okay, if this gets sure or a success, what is that I can get in terms of ROI, in terms of scaling? That's when you next go for the entire adoption. That's what we are talking about here. And this is one of the favorite slide of mine. This, we technically call it as digital maturity curve, or as you see here, the journey for digital transformation. In line with the process which I have explained, this is the other way of depicting it. The first one, what you can see is connect and monitor. What we are saying is today, first of all, we don't know how your existing assets are performing, right? Your molds predominantly. How the quality of the mold is, in what way it is failing, right? How it is failing. So first try to understand, get the status quo. That's what is important. The next one is, with that data, so you're connecting and monitoring it, now you have the data, now next go for the next level where you can go for analytics, right? We talk about analyze and predict. It's more about predictive maintenance based solutions, right? With this data, now you can go and analyze, right? But again, these are not automative systems. They cannot take decisions, automatically. These systems can tell you and predict and say, hey, probably with this mold machine or with this tool, this is the life what you can see, and again, it might get much more deteriorated down the line. That's what the information and the action you are supposed to take. The next phase is more about digitalize and transform. That's where you go to the next level. Wherein you go, you design intelligent and smart systems so that they can also take, I would not say 100% decisions, again, few decisions on behalf of you, so that critical elements can be taken care automatically, right? That's the overall thought. What I want to bring here is, I have heard words like, Foundry 4.0. I just brought this tooling 4.0 with my analysis. But the overall idea here is, you first monitor your field of molds, right? If you have set of plants, set of mold machines, set of molds, you understand what is happening, right? Understand how the cycle time is, right? That's what the step is. The next step is, once you get this data, right, now with this data, which is the real time, fed it into your scientific methods, scientific models. That's where I just coined the term called molding analytics, wherein you kind of, go understand what is happening inside of the mold. That's your physical mold dynamics, right? So that's what we're talking about. Now collect this, simulate this information onto your molds, because now you're not talking about visualized data or envision data, but real-time data. The data which is coming from your real-time environment, and then you're simulating, right? And then, better up the quality as well as, your processes. So that's the overall thought. So what I brought here is, this is what is called digital twin. So what we're talking about here is, you have the physical world, right? You collect your data, you store it, you transfer it, where you are going to analyze it, and then you're going to, from this analysis, you'll also doing various parameters and then running these scenarios on your simulations, and then you're taking the right decisions to optimize your processes. or your products as well. I mean, especially on the design front. So what I want to bring here is a story which we have recently successfully delivered for MG Motors. So what you can see here is in June 2022, MG Motors have released a press saying that using one of our IoT as a service solution, which is called MindSphere, they could able to get the relevant throughput, right? So let's spend some time in hearing this story. I mean, you can go to the pointers, but here is what happened with MG Motors. MG Motors has a paint shop. Now within this paint shop, they have live systems, but these systems are not connected. They have data, they don't know what to do with this data. Now what we have done is, we have took the data, right? Now the challenge is they have a KPI of number of, the cycle time KPI, the number of jobs per hour, KPIs, which needs to be addressed. They have a KPI of X and they are getting a KPI of less than X, and they are not able to understand why it is happening. Right? They have the data, they cannot do anything with that data. Right? I mean, they are not capturing the data, but they have the PLCs in place, but they are not able to do anything with this. So what we have done with that is, we kind of we pulled this data, right? We kind of provided them very good insights about what is happening with this data, right? Which you can see in the next slide, right? They can have a clear-cut real-time dashboards of what is happening at station-wise and also at the line-wise, at the process as a whole, as a paint shop process as a whole, on every 1 hour basis. Even though they are live, typically they look for 1 hour, what is the, JPH or cycle time at station level as well as line level. Now we have not stopped till there, right? The story which I was talking about digital twin, what we have done is with this real-time data, it is fed to a simulated environment. Technically within Siemens, we call it as technomatics. Technomatics have been used, and where you have a simulation model of the entire paint shop process, you have the real-time parameters, they simulate it in a real time. We call it as production replay, and they can see what is happening, and they can identify the root cause, right? So that's the kind of story which we have built for MG Motors. Now these are the couple of dashboards which you can see here, right? And yeah, let me go back. This is what Ravi Mittal, who is the director of manufacturing from MG Motors, talked about when he released this press, right? So yeah, so this is what is the simulated model, right? This is a plant simulation. We call it as factory twin. But again, we also have a product twin, right? So the whole idea is you should kind of think a way ahead in terms of extending your existing processes to digitalize, get the real-time, information, and then take decisions. So such a decision systems should be made available for you. That's the overall thought. And then, yeah, so what you can see is, much of the delegates here would have talked about this, but again, this is a summary of a connected factory or industry 4.0, or tomorrow it can be tooling 4.0. So yeah, so I think I am on time. So any questions for me, please feel free to ask. Yeah, thank you.
So please remain on stage. Yeah. Thank you so much, sir, for that session. May I please request you to be on stage with us just for another few minutes. May I request Mr. Panchal to join us up on stage and hand over the memento. Ladies and gentlemen, let's take this opportunity and thanks, sir, for joining us here for that wonderful presentation. Thank you. There you go, sir.
Yeah, it was really a wonderful presentation, and it is a need of our IoT and digital factories. So we wish that you should share in future something lengthy, how it will be useful for the tool makers and injection molders. So looking forward to. Thank you.